All right, so good afternoon again, everybody. Dave Angeletti here at Tradewin again. And now for our next session here in Joint Force Protection, I'm introducing Tim Fultmeyer from AeroVironment. And he's got the stage for the next 20 minutes. There is not a Q&A session at the end of this. Instead, I'll come back on as he closes and give you some outtake notes, and we'll be on from there. So with that, Tim, take it away.
Perfect. And confirming everyone can see my screen. Or is that true? Just making sure everyone, yeah, perfect. Okay, thank you. All right, so going back into this. So my name is Tim Fultmeyer. I run the computer vision machine learning group at AeroVironment. The group's name is LEAP, or Learning and Active Perception. We've been doing work with the DoD for quite some time. Everything from force protection to overhead imagery analysis, surface detection, runway damage assessment, and everything kind of in between. Our primary sponsor is Dr. Michael Chin over at Office of Naval Research, and we've been doing that for years, and started originally with the Martin Kruger SIBR, and it's kind of grown and blossomed into a new set of technologies that we have here today. So what we see as far as modern analytic requirements are really, first, be agnostic to modality. So you should be able to understand EO, IR, SAR, acoustic, everything in between, and making sure that you have a pipeline to be able to support that. The second is that we need to be able to support imagery of all different kinds of types. So everything from full motion video to live streams to satellite imagery to image mosaics and everything you could imagine. Building a system that allows for both edge and centralized processing, because our firm belief is the closer to the edge that you can get the sensor and the data, the more you can do with it, especially when it comes to autonomy and perceptive autonomy. And then really one of our core tenets that we've always embraced is that analytics aid, not replace humans. I don't think computer vision is there yet to that automatic easy button that it's everything's solved. But we know what it really works well at, and we know what it needs help with. And if you can design interfaces that really help that, you can get a long ways. Easily integratable. So having open APIs that can very easily share with others and other partners to expand what you can do. And that really goes into that last statement of, play well with others, because really no one company can do it all. And if you have a system that you're doing things and producing things that are really good, then others can be picking that up and doing even more things with it later on. So in our world, we see the world kind of broken into three different areas. We call it strategic support, which we do a lot of high altitude image processing for spotter geo. We have the operational and tactical support, which gives us a lot of the force protection, ISR type operations that we have with our cluster UI and Blue Hotel system. And finally, the edge support, which is everything that putting on a robot and the perception that you really get from that. And the important thing that we really take away from this is we treat those lines as historically they were very siloed off, and you have data that's produced in one and not really getting to another. We're making use of all of those different kinds of pieces of information to really fill out the picture. So if we get satellite imagery of a certain target, passing those kind of contacts and images off to your high altitude or your ISR assets to be able to pick them up for pattern of life, and then passing them off finally to edge support for precision strike with something like a Switchblade or a Coyote. One of the things that we've been doing for a long time is we focus heavily, because we're on the computer vision side, on annotation. So the better you can annotate data, the better you can run experiments. And the better you can run experiments, the more you can learn. And the more you can learn, you can obviously iterate and annotate better data from the beginning. And depending on what kind of annotation you're doing, you're going to learn different things. The concept of having a bounding box on something is great. But what you really want to do is provide information that the analysts would get themselves or better. So if an analyst is looking at a certain vehicle in IR, great that you found that it's a vehicle. Can you say what kind of vehicle it was? Can you say specifically what make and model it was? Can you tell me exactly where the left driver's side window is? And if you can do all of those things as part of that common processing, you can provide more information to the rest of your system. And when we don't have real world data, we use heavily the use of synthetic. And so these are models that we've obtained from both the gaming community and the IC community and the modeling simulation groups. But where some of this is really interesting is part of an ONR effort we're on called Teams with Dr. Peter Squire. And it's taking real world environments that have been synthetically generated so that you can generate and run countless simulations and missions through those real world environments. And you see an example of Quantico UTC up here where we're putting synthetic objects into those scenes so that we can both run through missions and understand where our autonomy fails, as well as run through missions to understand where are situations that we may want to learn more about from a computer vision standpoint. What we are providing as part of our system is effectively detection and sub-object detection, as well as key points for every kind of object we're looking for. So in the cases of Locust TK, we're finding tanks, and then we're finding hatches, and then we're finding gun mounts. Whereas in certain vehicles or people, you're looking for articulated models so that you can get pose and orientation and articulation out of those particular objects. And that allows us to do a lot more with it upstream. But really the first love that I have is object re-ID. So my belief is that everything in this world has a global ID that is unique and it's available for anyone to be able to use. And the more that you can get down to that individual ID, the more that you can get information that would allow the system and the users to do something with it, be it from pattern of life or correlation or long range recognition that you couldn't do otherwise. And that's something that we've really kind of baked into a lot of our products that we are producing. And to that end, the first product that I'm going to talk about going from highest to lowest in terms of altitude is Spotter Geo. And so we created the system as a way to take in high altitude, large format imagery for folks like D6N, Air Force, and DGS-4, all the way down to BAMS-D over in Pax River, to understand exactly what kinds of ships are out there and maritime objects of interest, both from a visual search, as well as classification, as well as change detection, so that we can automate and help them write those processes faster to get through more information and imagery faster. And that project really started out in FY17. Martin Kruger sponsored our work over in 7th Fleet, where we deployed for about 6 months out there and really just tried to learn how do analysts and ISs do this work today. And what we did was we did a rapid prototyping. So every single day we're going through and we're understanding exactly what problems do they have? How can we provide something to make that problem better? And if we can do that, then we can build a system that is designed for them by them. And that's really taken us far as getting the system and getting it out into a variety of different places. And you can see the timeline here as well. And what that system looks like at scale is you get a large image in, you're going through and pulling out all of the information that you could possibly want. And the best part about it is it's not just looking for certain kinds of ships, like capital ships or subs. You're looking for whatever objects have been deemed of interest. And some of our customers want big ships. Obviously, those capital ships are interesting. But some of our customers are very interested in analytics of small ships, things 40 foot, 20 foot, that you can go through and get and detect and understand a pattern of life day to day to day. And as new imagery comes in, you can exploit it, analyze it, and get it out the door and make it searchable. And what that searchableness really does is it lets you take any single image of any single ship and bang it against our database that tells you exactly when and where the system thinks that ship has been seen over time. And this works for capital ships where you know exactly the type and hull and class, but it also works for just about anything else that you could visually recognize. So think of Ro-Ros, think of LSTs, and other kinds of ships that you may be interested in. And what that really produces for the analysts is not only the detections and reports of those, but also the pattern of life of where are these things seen, how long have they been seen, and when did they come into port, where did they go out of port, where were they docked? And that helps with the future aspect of understanding what is their pattern of life. So the next thing that we really took then was, all right, we have a really good idea of how to do recognition of ships and how to detect them and EO and IR. What we want to do now is kind of expand that. And so take that over to the P8 community and start seeing from an altitude perspective, what can you do with that? So we went out with ONR and NWDC support to Baltops out in Iceland for a couple of weeks. And what we did was we flew on board the P8. We went through and detected and tracked all of the objects in real time on board that P8, and then provided in real time ID of each one of the ships that we saw, as well as linking those detections across missions, across time. And that was something that was really, really cool to see and get feedback from the ISs and the analysts that were working on that particular project. And that ability to really retain information through different flights allowed them to build a much bigger and better picture of the space and kind of summarize all of the imagery that they're collecting from all those different sensors. And as far as once we showed that concept, we got called over by Task Force 59 to come out to IMX 22 to do a very similar thing, but now instead of going on one single platform on the P8, they wanted to show what happens if we go across all of the different sensors that are out there and do cross-sensor recognition. So, for example, we had Martax, which is a USV. We had our Switchblades and Pumas and Anduril Ghost. And taking all of the different feeds that we get in there, summarize all of those so that at a moment's glance, I can tell you this mission set today across all of your assets saw this many unique ships, and here's where you saw them, here's when you saw them, and produce almost a visual summary of exactly their pattern of life, examples of what sensors you saw them from, in real time pull up the video feeds so that you can get more information of what they were doing, so that you can really start to neck down on who's important out there and who's not. And what we did was we were providing the video and wall and infrastructure out for Task Force 59 as they did this exercise, where all the video feeds that were coming from all the different vendors were coming through us. We were processing them and then sending all that information out for others to process on and to improve upon that model. So they had CCS, which is an IWIC PAC solution that was taking that in and controlling the UAS or controlling the individual USVs, so they could task and get more information now that we've told them something. And really, at the end of the day, what we were producing was clusters. We were effectively trying to automatically say, to the best of our algorithm's ability, how many unique objects of interest did we see out there, and what did we learn about that? Some of the other work that we do with ONR and others is exercises, and we strongly believe in the concept of getting out there and testing and exercising and learning from each of those processes. So much so that we're actually out there 29 Palms right now with a team that's flying a variety of different aircrafts, some ours and some others, and providing information back to the Marines in real time so that they can change their ConOps and provide information. And for this particular one, we were launching off of a Puma. We're using a Parrot and NAFI, as well as cameras and sensors that are on board different mounted vehicles. And what that does is effectively going through and detecting not only people and vehicles and military vehicles, but starting to provide threats and threat assessments in real time that can allow the commander to make decisions about what they're doing and after action summaries of what did they do wrong. And that's something that we very much found of value. And just some screenshots and examples from some of the work we're doing out there. The last really area that I wanted to make sure I brought up today of things that we think are interesting, we're calling navigation alternatives or GPS denied, however you want to look at it. And we have two different concepts of that. One of them is a system we're calling visual fix. So it's effectively face recognition for dirt. And we're using the same kind of pipeline and architecture that we already have to be able to go through and actually train a model to understand the differences between different areas on the ground, and not just do a feature matching, but actually understand through differences in things like parking lots. So if you imagine at Christmas, a parking lot may be filled with cars that have features, but in midnight, all the cars are gone. And the system has to learn what are good things to match on that are persistent over time. And so what we end up doing is actually training that specific set of models over all of the imagery and all of the imagery that changes, so that the system can direct and dictate how well the actual system is working and what features it should use as far as navigation points. Some of the other work we're doing for other groups are scene segmentation. So if we can do an understanding of where is okay to drive or fly and where is not an okay area to drive or fly, and we can integrate this as part of our detector framework, we can be informing autonomous vehicles for their ability to maneuver through spaces without having human involvement. And in this particular example, our customer went in and said, well, we believe there's going to be mines out in the water, but we don't know what the mines are going to look like. We just need to know where we shouldn't steer and navigate to. And so we were able to do a model that in real time, as the system is driving at 15 knots, going through and detecting what objects and areas are sufficient to drive or to navigate and which areas are not. And those areas, as those mines were found there, were deemed as not relevant. The customer is also using this particular technology for avoidance of things like shore or rocks from a navigation autonomous perspective. The second method that we really use here is what we're calling horizontal visual fix. So a lot of times you're not going to be able to get over into a nadir position, but you're able to use landmarks, especially large landmarks that be in a distance, to help with recognition and orientation in a almost navigating or orienteering type of sense. And if we can go through and recognize these objects based on either pre-trained 3D data that we have or things that we've been able to collect opportunistically from the wild, it allows them to understand exactly where their platform position is, whether or not they're in a UAS or whether or not they're in a USV for that individual purpose. And the more that we can understand about exactly where you are, the more we can inform the groups like autonomy and perception that are going through and trying to get better shots for us when it comes to sensor steering and sensor navigation. So I know that was a ton of information really quick, but I wanted to just at least get what we are interested in and what things we think we do pretty well on out there. And in summary, I guess we are very familiar and comfortable with the computer vision machine learning space. And we think that it has a huge potential to reduce operator time if used correctly. And having a common approach like the one we developed for Navy 10 Cap in Blue Hotel to be able to take in any kind of imagery from any kind of source allows for a huge amount of flexibility and data fusion for downstream platforms. And that data flexibility means that you are producing out of your system something that is usable and open to others. So we see ourselves as a bump in the wire. Any data that comes into us, whoever that's owned by, whatever data comes out of it, also owned by that same customer. So the more that we can leverage that kind of concept and capability, the better we can possibly do. And our focus has been low power and edge-based systems. So everything from NVIDIA to Qualcomm, that we can take those edge-based processing solutions and move that forward, if nothing else, to at least start triaging the data, if not so much more. And really the real-time alerting and flexible architecture allows us to be very, very responsive. So we understand that we don't know everything, but if we have a well-documented and well-defined architecture, as we are out in the field and as we're out getting feedback from customers, we're able to iterate very quickly. And that iteration is really something that sets us apart from others. And I guess sorry, question?
No, I thought you were done.
Yeah.
That's why I stepped back up.
Yes, I am done. I can be done.
All right, thanks so much, Tim. As I mentioned at the start here, we have a list of those who attended, and we'll share that with Tim, and they'll be reaching out to you in whatever way makes most sense post-event. So thanks everyone for your attention today. Thank you, Tim, and we'll be back in 5 minutes with our next session. Thanks again, everyone. See you on the other side.
Sounds good.